Here we've got my second video on absolute value inequalities. In this video we're going to look at a few different examples. And this first example that we have is really just a standard example. So this is more just practice of what was covered in the previous video. So what we're going to do is we've got our absolute value shown right here. And so what we have to do is we have to start by isolating that. So what I'm going to do is I'm going to start by subtracting 6 from each side. So we have 9 times the absolute value of 3n minus 2 equals 45. And then I'm going to divide by 9 on each side. And then we've isolated our absolute value. Oh, did I write equals? Whoops. And then after we divide by 9 on each side, we got the absolute value of 3n minus 2 is greater than 5. And so now, what we learned in the previous videos, that means that this value right here has a distance from 0 that is greater than 5. That would mean that if I come up here, we have two different scenarios. That means that 3n minus 2 might be greater than 5 itself, but it also means that 3n minus 2 might be less than negative 5. And like I said in that previous video, go back and watch it if you need to. We represented that on a number line to show why that's the case. And so now I'm just going to do some real quick arithmetic to try to solve these. So we have 3n is greater than 7. And then if I divide by 3 on each side, we get that n is greater than 7/3. Let's solve our other inequality over here. I'm going to start by adding 2 to each side. Then we have that 3n is less than negative 3. And then I'm going to divide by 3 on each side, and we get that n is less than negative 1. So we have really this situation. What that would look like on a number line is if I represent it, I'll kind of come down here and do my number line, because I think representing these values in a number line helps us interpret our solution. If here's negative 1 and here's 7/3, what we have is we have less than negative 1, so that would be these values. And we have greater than 7/3, which would be these values. Notice that I left them as an open circle because we're not including the 7/3. We're not including the negative 1. So whenever I have something like this, it's best to write it with an interval notation. And so to represent this interval on the left, we know that this goes from negative infinity to negative 1. I use the parentheses to show that we're not including negative 1. And then to represent this right side over here, what we're going to do is we're going to start at 7/3 and go up to infinity. So, like I said, this is just a standard type of absolute value inequality problem. And from here, let's look at some examples that might be considered exceptions. So, it's so important that we understand absolute value as a distance. And the reason I say that, because if we understand absolute value as a distance, then problems like these will not confuse us. But if we think of it as strictly an algorithm where we try to just, okay, I do something with a positive and something with a negative, and you're going to miss what's being asked here. So what this is saying in this first problem up here is it's describing this as a distance. And it's saying what values of k would give us a distance here that's greater than or equal to negative 11. And you gotta think, well, any distance is going to be greater than a negative because our smallest distance we can have to something is 0. We don't measure a distance as a negative. And so what I'm looking at here is any value of k when I substitute it in and I take the absolute value of it. And remember, absolute value, if I think of this as just algebraically, makes something positive, right? Because our distance is always positive. Isn't a positive number always going to be greater than or equal to a negative? So if I look at that, what this is going to be is this is going to be just all real numbers. You might see it written with that symbol, or you might just write all real numbers. Because any value of k is going to result in this left side of the equation being greater than the right side of the equation. And so likewise, if you come to the second one, you might get stuck here going, oh, it's a quadratic, this is going to be tricky. But then when you think about it, okay, what numbers would result in a distance that's less than 0? And you got to think, okay, no matter what we put in here for x, we are going to have a distance that at minimum, remember our smallest distance that we can have is 0 itself. So is there any number over here that would result in a number less than 0? Is there any way to take the absolute value of something? You see our absolute value symbols. Is there any way to take the absolute value of something and have a negative? And hopefully you're saying no, so any value of x here would result in a positive number or even 0 itself. So here, there is no solutions. There is no way to make this left side of the inequality less than the right side of the inequality, because this left side of the inequality will always be greater than this. So our first example is in all real numbers, and our second is basically no real numbers, or in other words, you might write no solutions here. And so these are two problems that I would consider to be sort of exceptions to the rule, and they really, I can't emphasize this enough, hinge on us understanding absolute value as a distance.